Evaluate nth roots and use rational exponents. Integers are positive and negative whole numbers. Everything in this set that's shown, and a million, negative a million, 43, 42, 40, all of those are integers. Every integer can be represented by these symbols. The bold Z and the double struck Z stand for Zahlen. It's just a German word for number. So if you ever see either of those two symbols, it just means every integer, the set of all integers. Here is an example of all integers from 1 to 20 and their perfect squares. And just as a recap, if you have an integer, let's say 3, and we square it, we end up with 3 squared, which would be 9. We could get back where we started by taking the square root, and that will get us back to 3. For now, we're just going to worry about the principal square root. Different ways we could show square of 9. And if you want, try all these in a calculator. So first, square of 9 can also be written this way. This 2 here that 2 tells you what type of root you're taking. Another way is 9 to the 1/2 power, and all of those equal 3. So if you had 9 to the 1/2 power, and let's say we squared that entire number. Well, you know from previous rules that if you have a power raised to a power, you can multiply the exponents. So this just becomes 9 to the 1 power, which is 9. It shows that 9 being raised to the 1/2 power is the inverse of squaring 9. B to the n power equals a. Likewise, the nth root of a is equal to b. This n right here stands for the index of the radical. Quick example, 3 squared equals 9. Likewise, the second root of 9 equals 3. 5 to the third power is 125. The third root of 125 is equal to 5. And negative 1 to the 7th power equals negative 1. The 7th root of negative 1 is equal to negative 1. Here's a list of integers, perfect squares, perfect cubes, perfect 4th powers, and perfect 5th powers. The ones that are highlighted are the ones that you should make sure you are familiar with. Memorize them as best as you can. They come up again and again. The numbers that are underlined, so for example, you'll see 64 here, and 64 here. Those numbers belong to more than one category. Now there are multiple numbers that belong to many categories, but the ones that I have underlined here will come up more often than the others. 1, as you could see, could be a perfect anything. All right, let's do some properties. So let n be an integer greater than 1, so that's key. And let a be a real number. All right, first, what if n is an even integer? So we're talking about 2, 4, 6, 8, so forth. So if you take the nth root of a number less than 0, so for example, if let's say we took the square root of negative 5, well, we know from before that, yes, this could give you an imaginary root, but since we're only dealing with the real numbers, this will not give us any real roots. What about taking the nth root of 0? Pick whatever you want. If you want the 6th root of 0, well, that's going to equal 0, because 0 to the 6th power is 0. And the last thing to remember is that if you're taking the square root, 4th root of a number greater than 0, you have two roots, a positive root and a negative root. So the 4th root of 81 is positive and negative 3. When n is odd, it's much simpler. You only have one real root in each case. For example, if you take the 3rd root of negative 8, that equals negative 2. If you take the 3rd root of 0, that's 0. And if you change it up a little, the 5th root of 32, that will equal 2, because 2 to the 5th power is 32. If you try with negative 2 to the 5th power will give you negative 32. So we can't have that be one of the answers. Okay? So with odd integers, you're going to have one solution. With even integers, you may have no real, one real, or two real solutions. So you have to be very careful when you're working with that. All right, let's try a few examples. Find the indicated root. So I have n equals 4 and a equals 625. So let's write it out correctly. So we're looking for the 4th root of 625. Okay, I'm taking the 4th root, so that means I have two solutions. I have positive and negative 5. And that's my answer. If you want to check, 5 to the 4th power is 625. And negative 5 to the 4th power. So negative times a negative is positive, times a negative is negative, times the negative is positive. So this is positive 625. Oop. Let's fix that. $625. Okay, what is the 3rd root of 343? Well, 3rd root of 343. So there's only going to be one solution. So I started off with a positive number here. I'm going to end up with a positive solution. And the 3rd root of 343 is 7. Last, take the 13th root of negative 1. Okay, I have an odd index and a negative. So my final answer is negative 1.